All right, hello students. This is going to be the first lesson for Unit 6, which is going to be about square root and cube root functions. So for this first lesson, we're just going to talk about rational exponents. And every time you hear the word rational, I want you to think of some keywords, maybe like ratio. Maybe when you ration, when you ration food, it's a part of the food that you're eating, parts of a whole, or you can think about the word fractional. And that's the way we're going to understand this lesson. If we hear the term rational exponents, we should think of exponents, which are the little numbers that go at the top of another number, and that they're going to be fractions. So yeah, rational exponents are exponents that are fractions. Oops, I spelled that wrong. And the way that's going to look like in a general term is what we like the term x whenever we're doing algebraic manipulation, and it's going to be to the power of m divided by n, where m and n are any numbers that are rational. And now for radical symbols, it's actually pretty interesting, because if we understand what this exponent represents, then we could write an equivalent form using radicals. And it's going to look something like this. So it's root n, which is indicated by that little n on the outside. And we have x to the power of m. So it's going to be equal forms that look different, but they do represent the same thing. They're equal. And this is how we kind of derive that equality. So if we have a term x to the power of m divided by n, that means we could separate it into two different exponents. Using some exponent properties, we are able to get that 1 over n and put it as a radical right here. And basically the only thing that we're going to be doing is we're going to get this n, and we're going to move it underneath as the denominator. Vice versa, if we have a fraction, we're going to get that n and we're going to put it outside of a radical. So that's going to be pretty much the process for these types of questions. So if we look at this first one, we have x to the power of 2 divided by 3. So first step is always going to be to bring the denominator, depending on where it is, either outside or inside. But here we have to bring it outside. That means is that 3 comes out, so now we have the radical, and that's the 3 that came out. The thing that's left over is the square, so we have a little 2 right there, so that's what comes out. Next thing, well actually real quick, I'd like to note that this is specifically called the cubic root, or maybe just the cube root. That little 3 right there indicates that it's a cube root. And it's called cube root because of 3 dimensions. In a 3-dimensional space, we like to think of cubes. Now it's going to be the same step for this one. We're able to take out a 2, so that means we have a 2x1. And this is our answer, and we also call this a square root. So this is a perfectly fine answer, but we could clean it up a little bit and make it look like this. Square root x with no to the power of 1 or no index of 2, which is that little number right here. And it just means the same thing. They're exactly the same, and there's neither of these are incorrect. It's just a matter of we use the square root so often that it takes a little bit too long to write the 2 every time when it's the one that we usually deal with. So whenever you don't see a 2 there, just know that there is a 2. It's just not, it's invisible. It's implied in the math. Finally, we have this 3, this 3 right here, and it comes out. So now we have the radical 3, and then everything inside. We also have a 1 there, but since it's just a 1, we don't need to write it. Now for these, it's the opposite. This number on the outside gets taken into the inside as the denominator. So our answer is going to be 4 over 3, or x to the power of 4 over 3. Very similar case, we have x minus 4 to the power of, well, that 3 gets under, so we just have 2 over 3. Super easy. Finally, this 2 goes underneath, so we have x to the power of 6 over 2, which is going to be x to the third. The reason why we have x to the third is because this is just a simple calculation. 6 divided by 2, that does simplify into 3. So this is the point of doing this. It's not so intuitive to see this expression and understand that it's going to equal x cubed. But if we rewrite it as a rational exponent, then we could see that we could cancel it out. I'll work on these real quickly. So we have a denominator. So it means we're going to take out that 7 and put it on top. We're going to take out the denominator. And the only thing that's left is the 6. The 6 stays there. That numerator is always going to stay there. We're taking out that 2. So we have a little square root 2 x minus 5 with a little 1. But like I said before, if we just have a 2 radical, then that means it's just radical. Then we have x minus 5, and that 1 doesn't change anything. Next thing, that 5 comes out again, so it's just like that. Keep everything in the parentheses. The parentheses are very important. So we're just taking out the denominator and putting it outside as this little index on the radical. Next up, we have our little house. We have a radical house, and now we're going to put things inside. So that means we do x plus 6 to the power of 3 over 8. It's that easy. So here, this one's a little tricky because we already have a radical. But no matter, or we already have a denominator inside of the radical. So when we do that, we kind of end up with 1 over 3 times 5. That's just going to equal with, by x minus 2, 1 over 15. So whenever we have two denominators, we have to multiply them. We don't add them. And finally, this 3 comes inside of the little house. And now we have 4x parentheses. We still have the 4, but it's the denominator 3. Hopefully you guys get the hang of this quick. But now we're talking about some inverse operations. And we're going to touch on some points that are going to be very fundamental to Unit 6 as a whole. So let's just check it out. So we need to know how to convert from radical to rational forms because it's helpful to solving radical equations. It's going to be a big point. It seems like we're always trying to solve for x in a lot of these algebra problems or a lot of these algebra, let's say, lessons. So let's look at this example. We have something like this. And this is the statement. It's saying that square root x, all of that to the second power is equal to x. Which looks kind of weird. Maybe we could think that those two things cancel out. Because, okay, so we get that first part, and that's equal to 1/2. Therefore, we have 1/2, x to the 1/2 to the second. So this is what we call an inverse operation. You see those two powers, we have a power to a power. And because of the properties of exponents, that means we have to multiply them. And if we have 1/2 times 2, they're reciprocals. So that means that the exponent multiplication is going to be 1. As a result, that means that the square root and the square are inverse operations. Inverse operations as in we add 5 or we subtract 5. They cancel each other out. We multiply by 5. We divide by 5. We tie our shoes. We untie our shoes. In a similar way, we could also say that the cube root and the cubic functions are inverse. And the way that we can make sense of this is checking out some examples of how we can use inverse operations. So check it out. That 4 gets on the inside. So now we have something like this. X to the 1 over 4. The question is, what inverse operation do we need so that we can isolate the variable? What will cancel out that exponent? The answer is a 4. If the properties of exponents means we multiply powers to a power, that means this cancels out. That's just going to give us x. That's what we want. So we're going to say power of 4 is the inverse operation. So if we have x to the fifth, we could also think about a root of 5. Root 5. That's going to cancel out the operation. And that does happen, so that gives us x. So that means the inverse operation of that is root of 5. Last one, we have x 2 over 3. All of that should be raised to the power of 3 over 2, the reciprocal, the fraction flipped around. That's because when these two powers multiply, they cancel out to 1, meaning we just have x. Or we would have to say that we raise this to the power of 3 over 2. So this is going to be a very important topic of Unit 6. And just in algebra in general, it's important to know what operations cancel each other out so that we could solve for x. But for now, it's important to be able to manipulate these types of exponential expressions algebraically. We want to be able to go between this form, which we have here, and to this form, and vice versa.